First of all, thank you everyone for attending this session where I'll be discussing about understanding enterprise integration patterns with Apache Camel. But before we dive into the topic, a little bit about myself. So basically, I'm a Java developer with close to 12 years of experience, and currently I'm working as a senior software engineer with Capgemini. But the majority of my experience goes into working in the risk space, primarily with financial institutions. So, what will be the agenda for today? Basically, we'll look at what is enterprise integration, why is it required, and then we'll see some enterprise integration patterns, like how they help in achieving or realizing enterprise integration. We'll also broadly discuss what is Apache Camel, a bit about its architecture as well, and what problem it actually helps us solve uh, in terms of implementing as well as using enterprise integration patterns in our day-to-day implementations and software architectures. So to start off with, the first question that we have is, what is enterprise integration? So basically, as we all are very much aware that usually systems are comprised of services, and basically services are more or less interested in some or the other kind of data. So when you have different kinds of services trying to interact with each other, they somewhere or the other prominently become dependent on three items. The first is the underlying technology or the medium which they are going to use to communicate with each other. The second one is the protocol, and the last one is the data format. But what usually happens is that if at all there is any disparity between the communicating services in either or all of these three mentioned points, the communication is not efficient, or it gets difficult to establish that communication. So in those cases, what usually happens is that we might spend additional hours trying to figure out how to get two services communicate with each other rather than focusing on the actual business problem, right? So what enterprise integration does is that it aims to standardize the communication between services irrespective of the underlying technology, protocol, as well as the data format. So it doesn't matter whether you have two services, one using Apache, let's say Apache Kafka or ActiveMQ, and the service at the other end is exposing its data with the help of, let's say, databases or a common file system. So we can see that there is sort of a disparity between the services which are trying to integrate. So if we are able to leverage enterprise integration, what we can sort of achieve is that we get a medium that has a standard mode of communication between these two communicating services. But the next question is, fine, I understand what enterprise integration is, but what I want to understand is, why is it actually required, or if at all it is actually required or not. So in an enterprise environment, these questions are not something based on whims. This is more to do with an architectural ask. So enterprise integration, it's not like I want to do it, that is why I have to do it, but it's a demand from an architectural perspective. Why? Because let's say I have service A and service B. They are trying to communicate with each other. The first and foremost thing that I would be looking forward to is an API, because without an API, or in the absence of an API, it's simply not possible to access the data on either side of the systems, right? So what enterprise integration will help me with, it will help me define clean APIs, which is fundamental, because unless and until I have a clean contract at my disposal, it's not possible to leverage the data that each of these services are holding. The next thing that enterprise integration architecture enables is loosely coupled services, which is very much important, because primarily what we are aiming towards is that our services must be cohesive, and at the same time they should be loosely coupled with each other. What that means is that there should be a clear demarcation in terms of what service A is exposing as well as what service B is exposing. There should not be a service overlap between these two interacting services. So loosely coupled services not only enable in easier testing, but at the same time we are clearly able to identify the domain in which we are operating. And the final one is that effective data management and governance. So like I said at the very outset, that at the end of the day, these services are tied to some or the other kind of data with them. So unless and until there is a governance mechanism in terms of the data that these services are exposing, it's of no use. So what enterprise integration, or why it's required, it's basically required for these three purposes. We are aiming towards cleaner APIs, that is a proper contract with the help of which these services can interact with each other. Loosely coupled services, which marks a clear demarcation in terms of the domain that these services are operating upon. And finally, there is a possibility to achieve proper governance as well as effective data management. That brings us to the next question, that how do we achieve enterprise integration? So for that, we have certain enterprise integration patterns with us. But what are enterprise patterns? So basically, it's a catalog. To be precise, it's a catalog of 65 design patterns, which are time-tested solutions. They basically enable an efficient and seamless collaboration of the communicating services. How? First of all, they help us realize a standardization of data formats. So let's say, for example, somebody is publishing JSON data, and at the same time, somebody is working or expecting a data in Avro format. So for the developer, on either sides of the system, it becomes an ask to make these things, to make these data formats compatible. But what if we have a mechanism, or we have a design standard with us that sort of enables us to achieve standardization of the data formats between these two communicating services? Life becomes very much easy, because then we are more or less able to concentrate more upon the business problem at hand, rather than trying to figure out how to get a particular data format compatible with the another format. The next thing is monitoring and error handling. So like any services at our disposal, failure is something that is inevitable. You are bound to have some or the other kind of issues in the services that are operating. So we have certain set of patterns that help us implement monitoring much more effectively, rather than trying to devise something from the ground up level. It is sort of trying to reinvent the wheel from zero. At the same time, there is a clear segregation in terms of how we want to deal with our errors. So it's not like that all the errors are supposed to be handled in a generic way or in a generic manner. Each error has a particular use case as to why it is there and what sort of problem it depicts. So in order to achieve a clear segregation as well as better monitoring of applications, these patterns are really helpful. The second is the security consideration as well as integration architectures. So enterprise integration is not something that is limited to just two services. You are going to have a myriad number of services, right? So when you have so many services trying to interact with each other, trying to share the data or some information with each other, security becomes of paramount importance. And that is why enterprise integration patterns define some clear security standards as well as patterns, which somewhere or the other encapsulates our services in a better manner, so that we achieve proper governance in terms of what our API is exposing and what is actually supposed to be exposed, right? But the question that now comes into the picture is that how can Apache Camel help us in realizing or answering all the three previous slides that we saw? So in a nutshell, Apache Camel is basically an open source integration framework. So what does that mean? It simply means that out of all the 65 integration patterns that we have at our disposal, Apache Camel takes care of implementing all those patterns for us, so that we can simply concentrate on implementing the business logic that we are supposed to work upon, right? So like I've written, it's basically an open source integration framework based on enterprise integration patterns. It enables to achieve service to service communication irrespective of the underlying transport or messaging model. Like I said, services, someone is expecting JSON data, somebody is expecting Avro data, or the protocol, whether it is HTTP, Kafka, ActiveMQ, you name it, right? Or the data formats, right? So it's sort of a platform agnostic approach towards integrating various services that we have at our disposal, right? So a brief look at the Camel architecture. So at the heart of it, we basically have a Camel context. So like for Spring applications, we have a Spring application context. For Camel applications, we have a Camel context. But what does the Camel context offers us that helps us realize enterprise integration or helps us implement our business functionality with the help of using enterprise integration patterns? So we basically have a routing engine. Our routing engine basically defines routes. But what is a route? So a route is basically a path between two interacting services. So let's say service A is trying to interact with service B. you will obviously have some way to define a map or a route. So that route is basically defined with the help of a route. Secondly, we have certain components. Now the components are the actual items that we are looking for. Why? Because these are the entities that will stand opposite to each other, who will be trying to communicate with each other, right? So at the end of the day, you'll be having n number of components who are trying to communicate with each other. At the same time, we'll have message processor or filter. So we have components, that's fine. But components need an identity. So components, when I say they need an identity, components are identified or they are encapsulated with the help of an endpoint. And endpoints usually have a unique URI to identify themselves. So let's suppose I have a file endpoint with me. That file endpoint will be uniquely identified with the help of a URI. And at the same time, if it is transferring data over to another system, and let's say that is exposing the data with the help of HTTP. So that HTTP in itself will be encapsulated in an endpoint, and that endpoint at the same time will have a unique URI to identify itself. But what are message processors? So message processors are actually the meat of the entire system. Why? Because they help you implement EIPs. Now this might sound a bit confusing. I'm already discussing EIPs, but how can a message processor help me implement EIP? So the way it works is that between two communicating services, let's say service A and service B, I can have n number of services in between these two services, right? So in order to interact with these in between services, I can leverage further more enterprise integration patterns, right? So that is a place where processor helps us out to build that intermediate path. At the same time, routing considerations, like I said, between two services, if there are n number of services, the routing between those n number of services before we reach the final destination, it gets taken care by with the help of routing. Finally, transformation. So what is transformation? So transformation is the data. Let's suppose we have a service that is transferring some data over to another service. Now the data that is in transit, it is subjected to certain how do you put it? So you can have certain business checks which are preconditions. We can have certain post conditions, and at the same time there will be something in between, right? It might be so that you'll change the nature of the data, right? Let's suppose I'm transposing data, right? I'm transmitting the data in a particular manner, but the receiving system is actually expecting an enriched version of that data. So how do I take care of those enrichments? How do I take care of those business validations? That is where processes forms the backbone. It is the processes where we are able to define our business logic, business use case, whether it is preconditions, post conditions, or validations. We'll see it with the help of code as well. Secondly, like I said, enrichments. So enrichments also form part of transformations. So transformations can be translations as well, where you are actually changing the format of the data or changing the actual data that was transmitted, right? Validations, like I mentioned, and finally interception. So in a nutshell, if you look at the Camel architecture, it is basically providing a framework where you can leverage all these individual items, starting from components to the routing engine as well as message processor, to help yourself an effective architecture targeted towards building proper API-driven services. So whatever I discussed, I would like to now explain that with the help of an example. So let's suppose we have a new pizza parlor in town, and the guy there has decided to go online with his services. So the architecture diagram that you see in front of yourself, I'll break down this architecture trying to implement the patterns that we have at our disposal and how can we integrate different segments or different services of an overall architecture to form an effective or large scale architectural program. So let me just bring you over to this thing. So let's suppose a typical pizza ordering process takes place in these number of steps. So the first step would be that a client sends an order. So we have the order service with us. Once we receive the order, we persist that information into the database. Secondly, once the order has been registered into the system, we send that order to be processed. Now you can see that here we have two services who are trying to communicate with each other. That is, order service is delegating the order that it has received to the processing service. Now obviously, processing service will have its own set of, it can be checks or anything, but yes, processing service has certain responsibility. So when two services are trying to communicate with each other, we can see that there is a medium in between. That can be a queue, it can be a topic, it can be pub sub, anything. But the point here is that we are implementing a pattern over there, and that pattern is the point-to-point pattern, and it is one of the enterprise integration patterns that we have. There are many patterns that we use out of the box without even knowing that these are well-known enterprise integration patterns. But like I said, that between two communicating services, whatever order that the system is receiving, it is simply publishing a message to the next service, that is the processing service, to process that order further. The next step is that we want to split this split the order that we have received. So the way this business works is that there are two possibilities. Either you can have a takeaway order, or you can choose to dine in, right? So this is a business decision, right? Trying to figure out what the nature of the order is, and accordingly delegate the respective services who should be dealing with the respective order type. So to bifurcate this order into two parts, we have the splitter pattern in between. So what does the splitter pattern do? The splitter pattern is basically, let's suppose you get an order, and that order has n number of items into it, right? So some orders can be takeaway orders, or some orders can be dine-in orders, right? And each orders will have some specific use case relevant to them only. So there might be some use cases that are applicable only to takeaway orders, and some might be applicable only to the dine-in orders, right? So what the splitter pattern will do is that it will get the entire gist of orders that it has received. So it will get the entire order block and start splitting it into individual items. So as a developer, I don't have to be concerned about what the splitter pattern does. What I need to be concerned is with the fact that how do I want the splitter pattern to work? I have to provide it with a criteria based on which the orders will be broken down into individual orders. So the composite order gets broken down into individual orders. So my ask is that I'll provide the logic, splitter pattern will do the work for me. It is out of the blocks implemented for me. Once the order has been splitted, the next pattern is the recipient list pattern. So what is the recipient list pattern? So we might have come across several business use cases wherein we are not sure of the final destination where a particular message needs to be delivered to. So for those use cases, we have the recipient list pattern. It basically implements, it basically provides a way of implementing dynamic routing mechanism based on runtime business conditions. So when the order gets broken down, the recipient list pattern will get the first order and it will check whether it's a takeaway order or whether it's a dine-in order. And accordingly, it's going to bifurcate the that order to the respective process. Now you can see that there is a small, there's a blue highlight between service to service communication. So this blue highlight basically represents a route between two interacting services, right? So order service to process service, it will be defined with the help of a route. But there is a defined, or there is a domain specific language to define this route that you can see at the top with the help of an arrow that I've shown. So this is the camel syntax of how you basically define a route when you have interacting services with each other. So similarly, when the order gets broken from the processing service, there is a route between the processing service and the takeaway part, as well as a route between processing service and the dine-in part. So you can say that the takeaway and dine-in is a logical segregation of the processing service. So the actual service is the processing service, but there is a logical segregation in terms how the orders are to be dealt with. And finally, when the respective orders are ready with us, we again publish a message onto our queue to inform the notification service that the particular order has been prepared. But at the end of that pattern, we have aggregator pattern. So let's suppose I, as a customer, I order 4 pizzas, right? 2 of which are takeaway pizzas and 2 of them are dine-in pizzas. The splitter pattern breaks that order into 4 individual items. Each and every single item gets processed based on the type of the order. And once these orders are ready, I have the aggregator pattern to aggregate that entire order block into that composite form the way it was received from the client. So aggregator pattern is basically the pattern that you would use to group together individual messages or individual items of a composite order into a single item. So this is the overall flow of a pizzeria application. The guy who has decided to go digital with his pizza shop. Now we'll see. Just a second. Yeah. So this was the use case, and now what I'll do is that I have a simplified version of the code that sort of implements this, just to convey the idea in terms of how we can leverage Apache Camel to our advantage to realize this functionality with us, right? So yeah, so if you plan to use Apache Camel to integrate your services in your enterprise, basically you need a routing engine, right? So Apache Camel provides this route builder. This route builder is basically the route engine where you are expected to define the routes or the path that 2 services will use to communicate with each other. How do we establish a route? To establish a route, we basically need endpoints. So let's suppose this is the order publisher and this is the order service. So there is a route between these 2 endpoints, right? And these endpoints. So right now it's an in-memory route, but let's suppose we had something, let's say we are publishing the order to a Kafka queue, then the syntax would probably change. And based on that protocol that we mentioned over there, the endpoint gets binded to the particular or the respective component. If you could recall from the Camel architecture, I had touched upon what components are. So at the end of the day, it's basically components who are interacting with each other, but the way you identify components is with the help of these endpoints, right? So these are the services that we have that are from that particular architectural diagram that I had shown. So route between order publisher and order service. So we have the publisher that is publishing the order, and then we are splitting that order, right? So the split is the implementation of the splitter pattern. But if you see that we have the order splitter over here, so order splitter is nothing, but this is basically a component class. This is where we are interested in. This is where I am defining the rule based on which the order has to be broken down, right? It's a very simple, or you can say it's a very naive example, but yes, just to convey the idea, I am basically returning an iterable type. Here in this case, it's a list, but it could be anything. You just need a criteria that defines how this splitter pattern is supposed to break down your orders. Moving ahead, once the order has been broken down, we receive the order, the received order is delegated to the processing service. What the processing service does is that it has the implementation for the splitter pattern and it breaks the orders. But after breaking those orders, we saw that there was an implementation for the recipient list pattern that was trying to figure out the next destination, and that destination was dynamically driven based on the type of order we have received, right? So in order to implement a recipient list pattern, or rather the business use case, so I won't be implementing the recipient list pattern. I just need to provide it with the logic that the recipient list pattern could use it to its advantage to realize the final destination. So the way we do that is with the help of a router. So this is basically a Spring Bean, and what it does is that it checks at runtime the current object or the current order. What is the type? Is it a takeaway order or is it a dine-in order? And based on this check, we are able to decide the final destination where it needs to be delegated. So we had two segregations. The first one was the takeaway service, and the another one was the dine-in service. So this happens at runtime. And who is doing this thing? This is being done by an implementation of the recipient list pattern, wherein I'm just mentioning the business use case. I'm not touching upon what that pattern is. So next that we have is, of course, takeaway orders will have certain business preconditions or post conditions. It might have certain validations, or it might even have another route to some other service before it reaches the notification service. So where do I do that thing? We do that thing again in a Spring Bean. So if I could emphasize upon it, you can see that I'm basically using a Spring Bean, and in that Spring Bean I have a method, that is the prepare takeaway method. So yeah, this one is the method, right? This is the area where you are going to apply your business use checks, right? So nowhere am I working with the actual pattern itself, but what am I concerned with? I'm only concerned with the business use case that is at my disposal. I need to bother myself with this, right? And I have a similar implementation for the dine-in order as well. If you could recollect, a while ago I mentioned that the Camel context or the overall Camel architecture provides me a component that is called the processor, right? So you can take this as your processor. So processor is a very, what I can say, mild version if I compare it to a bean, because a Spring Bean has far more capabilities when compared to a simple processor, right? But this is the area where you should be able to define new routes prior to this order type gets delivered to its final destination. This is the area where you should be able to apply your filtering checks, data validations, data transformations, as well as translations. So transformation comprises of translations, but it is not necessary that a transformation will necessarily translate the underlying data, right? So the way we are transmitting, if I am transmitting, let's say A, I'll be getting A at the other end. But at the same time, it is very much possible if I am transmitting A, I might do some processing that eventually lands up as ABC, right? So there is a slight difference in terms of what do we mean by transformation, translation, and at the same time leaving the data untouched. And finally, what we have is an implementation of the aggregate pattern. So if you could recollect that once the takeaway order as well as the dine-in order are ready, we publish a notification to the notification service. But before we do that, we aggregate the entire orders. So I ordered 4 pizzas. I broke down those 4 pizzas into individual orders. I applied certain business checks to each of those individual orders, and now it's time to accumulate all the individual orders into the state that I had received that order, right? So the way I do that is basically with the help of the aggregate pattern. So aggregate pattern will implement the pattern out of the box for me, but I need to provide it with a logic, with a business use case, that how am I supposed to aggregate that, aggregate the overall order, right? So for that, what we can do is that Apache Camel has some predefined aggregation strategies, and on top of it, we as developers have the liberty to define newer strategies of aggregating the data in consideration. So in this case, this is the logic that I have implemented for aggregating the pizzas. So the first order that we receive, so old exchange is basically the first order that we receive, the first time that this service is hit. And the newer exchange would be the subsequent requests that keep coming into the system. So I have a composite order, it gets broken down into 4 orders. So each and every new order that gets transferred to this aggregate method will come as part of the newer exchange, right? But to aggregate the data, we are sort of dependent on 2 items. The first is the correlation key, and the final is the expression that defines how the aggregation is supposed to stop, right? So if you can see over here, this method. So I have another bean called the waiter, and inside that waiter bean, I have a method called check order, right? So if we can quickly see this. So this order number, this will be a unique key for the orders. So I am basically aggregating my order based on the order number that I have pertaining to that particular order. So all the individual or segregated orders belonging to this particular order number, the aggregator will help me aggregate it out of the box. So I just need to provide the criteria based on which I want to aggregate my orders, and the pattern will get it done. So it's eventually the business logic that I'm concerned with rather than the pattern itself, right? And yes, finally, once the orders are with us, we can very well invoke the prepare delivery, and we are off to delivering the pizzas. So I can run this program, but what will happen is that so yeah. When it's a takeaway order, it will reach out for the particular method in the pizzeria class, and inside that pizzeria class, it's going to invoke the method for the takeaway bit and apply business check and business rules for that particular takeaway order. And similarly, when it's a dine-in order, it's going to apply the business check and business rules for the dine-in order. And eventually, once this process completes successfully, you have your pizza ready, although we can't eat it. So yeah, this is a very simple example of how you can leverage Apache Camel to work on endpoints, build routes, and delegate your calls within processes. Of course, it's a very simple application, but in the real world, you might be having these endpoints as much more complex services who might have a more complex API or a contract for exposing the data. During those times, you don't want to bother yourself in trying to figure out how to get things working in the event of disparate data formats, in the event of disparate protocols. You can obviously give Apache Camel a consideration to integrate your services. So moving back to the presentation, we saw a couple of patterns in the form of splitter pattern, the aggregator pattern, as well as recipient list pattern. The router is basically the recipient list pattern. But these patterns are, at the end of the day, are Lego blocks that you can stack on top of each other to build a composite pattern. So the pattern that we have in front of is basically a composed message processor pattern. So this pattern is basically, it's basically forming with the help of individual enterprise integration patterns integrating with each other to give rise to this overall pattern. So this is basically what we implemented. We had the pizza order, we splitted that order, we routed that order into takeaway as well as dine-in, and eventually we aggregated the overall order to receive the order back in its initial state. And just a food for thought before I end the presentation. This is the overall map of enterprise integration patterns that we have at our disposal, starting from endpoint A to endpoint B, and in between, it's depending on the business use case that you have at your disposal, whether you want to use pub sub, queues, topics, or it might be so that application A is publishing data over with the help of a database, and application B might be consuming that data. At every stage of this communication between these two services, we have some or the other pattern available with us at our disposal to make this overall architecture neat, clean, and less clumsy, right? So that is all that I had to present with regards to enterprise integration patterns with the help of Apache Camel. If there are any questions, I'm ready to take them. Thank you.
Okay, we have one question. Oh, tools.
Yeah.
Debugging issue
Yeah.
with the Camel.
Yeah.
From your expertise, do you have any tips?
Well, what you can do is that we can always leverage route IDs. We can leverage route IDs to uniquely identify the routes that are currently facing problems. We can have effective logging mechanisms in place. The way, see, I understand that debugging Camel applications is a bit of a soup, but why is that so? That's mostly because we have independent threads coordinating with each other. That is where it becomes difficult, right? We have an overlap of logs where we are not able to effectively understand the flow of data that gets broken down. So if you'd ask me, the way I would do is that, first of all, I'll start off in a single threaded model. Secondly, I'll have effective logging in place. And the next thing that I would have is that I would try to identify each and every routes that I have interacting with each other, get identified with the help of a route ID. That is the bare minimum thing that I would have like to have in my checklist before I try to dig into something more serious. Yeah.
To be honest, I wanted to ask a really similar question.
Okay.
So maybe I will add something more. How to set up everything locally, because on the diagram you just show us many different services. So how to test it, how to set up everything locally?
Okay, so the implementation, the implementation that I had with myself, it was completely a in-memory implementations, right? So first of all, as I was using Spring, so Spring sort of gives me the entire context ready for me, right? I have Camel starter package available with me, so it sort of establishes the entire framework for me. I just need to pull out the route builders to declare my routes. The second thing is that obviously, if I keep aside the in-memory bit, and if I have actual services in place, then you would obviously need to have, let's say, an actual active MQ in place upon which I'll be publishing the messages. And at the same time, I'll have an actual service that will be consuming the messages of the queue, right? So what will happen here is, I'll take this example again from publisher, right? So the publisher is the endpoint. It's an in-memory endpoint, right? Direct pizzeria. That endpoint would be defined with the help of a, let's say, Kafka : the queue address, or if it's an ActiveMQ queue, ActiveMQ the queue name, right? And at the receiving end, which is the order service will be reading from that particular endpoint queue. So rather than having an in-memory thing in place, I would be having actual components that are interacting with each other. I hope that answers the question. Yeah.
Thank you. Do we have any question? Okay, Shouvik, thank you very much.
Yeah, thank you.